Hello and welcome. In this video I'm going to play around with my A-star search algorithm and greedy search algorithm and explain the differences between these two powerful algorithms. So as you can see, these two algorithms both can reach the destination, but they just don't always return the same path. The reason being is the nature of the algorithm itself. So in this video I'm going to visualize the process of the algorithm by doing the heuristic function step by step, following up by the pseudocode. And as you see, we got a pseudocode here. Not sure if you can see the text properly, but it was taken from Wikipedia. And I have a little heuristic calculator here I just written to help me to calculate values. And this is where I do the note taking, and this part will be very important in this video. First of all, I would like to start looking at the A-star search. In this example, I will go from node 19 to node 4. So we set our starting node and goal node to be 19 and 4. And then followed by the pseudocode, we add our starting node into the open set, which is 19, and we create an empty map that is called came from, which is what we have here. And then we initialize the G-score value and F-score value for every single node. By default, they will have an infinite value for G-score and F-score, except the starting node. So I put starting node into the open set with 0 for G-score, and I also need to know the F-score for the starting node. So F-score in this case means the straight distance between starting node to the goal node. So it would be 30.1. And then we finish the first part, we can start looking at the while loop. Within the while loop, the first thing we do is to look from the open set and select a node that has the lowest F-score value. But in this case, we have only one node in our open set, so we definitely choose 19 to be our current node. And after 19 is being selected, we try to compare to see if the current node is the goal node or not. In this case it is not, so we can skip this part and we look for the next part. We got another for loop here. What this for loop does is to get the neighboring node of the current node and try to compare the G-score value to see whether or not to add them into the open set. So first thing to do is see what neighbor node do I have. So I have 18 and 7 for the neighbor node. I put it down. And so firstly I will try to calculate the tentative G-score value for 18. So the formula for tentative G-score is the G-score of current node plus the distance between current node to the neighbor node. We already know that the G-score value for 19 is 0, so simply it will just be 0 plus 10.32. So the G-score, tentative G-score value for 18 will be 10.32. And then we try to compare the tentative G-score value to its actual G-score value. And as mentioned before, all nodes will have an infinite G-score value to start with. So in this case, the tentative G-score value is less than the actual G-score value. So we can safely add this neighbor node into the closed set. And then we calculate the F-score value for this neighbor node. So the F-score value is G-score value plus distance between neighbor node to the goal node. So So it will be 35.13 plus 10.32. And 45.45. And then we start to calculate node 7. And again the G-score value for current node is 0, so the tentative G-score value for 7 will be 0 plus 11.30, so it will be 11.30. And we add that into the closed set, and the F-score value for 7 will be 35.99 plus 11.3. Right. And then we also don't forget to add them into the came from map. And then our first iteration is done. We can start our second iteration. So again, we need to look from the open set and choose one that has the lowest F score. So in this case it will be 18. So we select 18 to be our current node and get the neighbor node of 18. It will be 17, 42, 20 and 19. So alright, so the tentative G-score value for 17 will be 10.32 plus 10.08. And then put that into the closed set, and the F score value for 17 would be 45.09. 20.4 plus 45.09. And then the tentative G-score value for 42 would be 10.32 plus 11.38. And the F-score value for 42 would be 21.7 plus 17.8. Tentative G-score value for 20 will be 18.43. Alright, so in this case, since number 19 already exists in our closed set with a lower G-score value, so it does not meet the condition to put in the open set. Right, so then in this case we have to abandon 19. So now let's start our third iteration. So again, we choose the one that has the lowest F score. So in this case it will be 20. So we choose 20 to be our current node. And then what The neighbor node we have 18, 21, 27, 30, and 18. And the G-score value for 18 is the G-score value for 20 plus 8.11. And since 18 already exists in our closed set, and it has a lower G-score value, which means again we have to abandon this neighbor node. So we don't go any backward. So we start looking at 21. Tentative G-score value for 21 is 11.99 plus. So the tentative G-score value for 21 is 30.42. F-score value will be 30.42 plus 17. G-score value for 27 would be tentative G-score value for 30 is 31.58. And the F-score value will be 31.58 plus 18.96. So we finished our third iteration and we can start our fourth iteration. So in this case, which is the one that has the lowest F-score, this time it will be 7. So we choose 7 to be our current node. And then we get the neighbor node of number 7. So we will have 14, 8, 19, and 6. And the tentative G-score value for 14 would be the tentative G-score value for 14 would be the G-score value for 7 plus the distance between 14 to 7. So it would be 10.24 plus 11.3, and then add that into the closed set. And then 46 pounds. And then about number 8. Alright, since 19 already exists in the closed set, so we need to abandon it and we go to 6. Let's see. So the tentative G-score value for 6 will be 11.3 plus 12.4. F-score value for 6 will be 23.4 plus 24.1. Alright. So we finish our 4th iteration. We can start our 5th iteration. So again, in this case, which one has the lowest F-score? Seems like 6, so we choose 6 to be our current node. And what's the neighbor node we have for 6? 7, we have 5. So the tentative G-score value for 7 will be 23.4 plus 12.1. And again, since 7 already exists in a closed set with a lower G-score, so we have to abandon 7 and we go for 5. And the tentative G-score for 5 will be 23.4 plus 10.4. Here we go. And the F-score value for 5 will be 33.8 plus 13.7. Okay. Okay, then we finish our 5th iteration. We can start our 6th iteration now. So in this case, which one has the lowest F? Alright, 5. And then we choose number 5 to be our current node. So number 5. And what neighborhood does it have? 6, 2, 4. And we calculate the tentative G-score value for 6, so it will be 33.8 plus 10.4. And again, 6 already exists in the closed set with a lower G-score, so we abandon 6. Go for 2. So the tentative G-score value for 2 will be the G-score value for 5 plus the distance, so 43.75. And the F-score value for 2 would be 43.75 plus 17. Finally, 4. So the tentative G-score value for 4 would be 33.8 plus 7. And the F-score value for 4 would be 47.5 plus 0. So 47.5. And we finish our 6th iteration. Now we can start our 7th iteration. So in this case we have 4 as the lowest F-score value, so we choose 4 to be our current node. And in this case we check the condition to see if the current node is the goal node or not. If it is, we can just safely return the path. So In this case 4 is the gold node, right? Yes. So by doing that, we can see the reconstruct function here. Simply we will just trace all the way back. So 4 came from 5, and 5 came from 6, 6 came from 7, 7 came from 19, and then we reverse the list. The result will be 19, 7, 6, 5, 4. So the correct sequence of the path will be 19, 7, 6, 4, 6, 5, 4. This is the order for A-star search algorithm, and let's see how it works. So I'm here 19 and I go to 4. So 19 7. Right, and that's how A-star search algorithm works. Next, I would like to talk about the second algorithm, which is greedy search. Greedy search, as you see, greedy search works a bit different from A-star search. It goes another way around. And technically, greedy search is easier to understand than A-star search because its structure is very simple. Like, we don't need anything like open set, closed set, came from, or G score, F score, anything like that. We only need two lists. One is called pent list and another one is called path. So what pent list does is, every time when we visit a node, we will put the node into the pent list to guarantee we don't visit the same node twice. So in this example, I would like to go from 19 to 4 again. So first thing to do is to add our starting node into the pent list, and then we look for the neighbor node of 19. We have 18 and 7. And next we need to know the distance between the children node to the gold node. So the distance between 18 to 4 is 35.13, and the distance between 7 to 4 is 35.99. After we get the distance, we need to sort the children in ascending order, and this order seems correct, so we can just start the for loop. So first thing to do is, the first iteration, I need to check whether the first children is painted or not. If not, add it into the painted list, and then check to see if it is the goal or not. If it is not, we can skip this part. And then we need to start a recursive call from here. So which means we need to look for the neighbor node of node 18. So here we go. We have 17, 42, 20 and 19. It's the neighbor node. And alright, because 19 is already inside the pent list, so this time I just get rid of it. So distance from 17 to 4 is 45. Distance from 42 to 4 is 3. And again, we need to sort them in ascending order, so it will be like this. Alright, and this is our second core tree. So from here we need to start our for loop, see if 20 is pended or not. If not, add it to pended is, and it's not go. So we start our third core tree from node 20. So we look for the neighbor node of 20. We have 21, 27, 30, and 18. And since 18 is already inside the pended list, so I get rid of that. So distance from 21 to 4 is 37.93, and 27 be 26.65, 30 be 96. So we saw them again. So node 30 is the first child, and then our third core tree is finished. So we are about to start our fourth core tree. First, to put 30 into the pended list and get the neighbor node of 30. So we have 20. Since 20 already in the pended list, so I ignore it. So we have 29. So distance between 29 to 4 is 8.37. And then we start another core tree from node 29. We have neighbor node 28 and 4. So distance from 28 to 4 is 12.91. And distance from 4 to 4 is 0. And then we finish our fifth core tree. So we are about to start our sixth core tree. So before it starts, we need to sort it in ascending order. And then we check the first node, the child node. Okay, 4. Add 4 into the pended list. So check if 4 is the goal or not. In this case, 4 is the goal node. So now we need to add 4 into the path list. Okay, then add 4, and then we return this path to the previous core tree, which is here. So 4, and then 29, and then 30, and then 20, and then 18. Alright, and finally we also don't forget to add the starting node at the end of the path list. So this is what we have, and then we need to reverse the list. So the result will be 19, 18, 20, 30, 29, and 4. And this will be the sequences of the path in greedy search solution. Let's see how it works. So 19, 18, 20, 30, 29, 4. Alright, seems correct. Before concluding the video, I would like to talk about some special cases in greedy search algorithm. Like, greedy search algorithm does not guarantee you can definitely reach your goal right? It does not have the best accuracy as A star. Like for example, if I want to go from 3 to 11 with A star, that is possible. But if I go with greedy search, I will finally end up stopping at the corner. The reason being is the nature of the algorithm, because I'm going to do a very quick run, but this time I'm not going to do any heuristic calculation. So if I go from 3 to 11, I will first select my neighbor node, which is 4 and 2, and then we compare the distance. 2 has the closest distance to 11 than 4. So in the first iteration I will go to 2, and then in this iteration I will select the neighbor node of node 2, which is 1 and 5. So, and again 1 has the closest distance to 11 than 5. So in the second iteration I will go to 1, and then in the third iteration I can go to 0 only because the previous node is already painted as I just visited before. So in the third iteration I will just end up in node 0, and once we cannot find any neighbor node to visit, we will just return the path, which will be 0, 1, 2, 3, and then we can never get around. That is the disadvantage of greedy search, right? It does not have a good accuracy, but it is fast.